right, here we go. Take 3. I thought my mic was on. I got all the way through the lesson and realized it wasn't on. All right, so hope you guys are doing well. I hope you're behaving. Not giving Mrs. Wasala too hard a time. I'll be back someday. Okay, so today we're going to talk about some more transformations and more specifically rotations. And this is not at all taking the wax paper and turning them. Okay, we're not allowed to do that when you hit big time geometry, although I still turn my paper sometimes. I'm not going to lie. So we're going to learn how to rotate a figure in a coordinate plane and how to find that angle of rotation. Basically, a rotation just takes a figure. There's a big bad definition. You don't have to write it down. You do have to know that we do have a center of rotation, which is the point that we're going to rotate something around. A lot of times, if we're doing it in a coordinate plane, it's 0. But basically, a rotation is just a turn. You called it a turn at one point in your academic career. Okay. So let's take my favorite mascot, my Nittany Lion, and let's rotate him. So notice that his orientation didn't change, meaning we can still read the Penn State and the flag correctly. It's not a mirror image. His size didn't change. Shape didn't change. So if you recall, that is an isometry. I bet you see a question on your test or quiz on this that says, hey, list the isometries from the transformations that we've learned. Okay, so let's go ahead and let's just get down to it. When you're not told which way to rotate, we're going to go counterclockwise. In this digital age, I shouldn't be surprised that some people don't know the difference between clockwise and counterclockwise. If you're not sure, look above the classroom door. Take a look at that little red hand. It's the second hand, and it's rotating around your circle. The direction that it rotates, which would be this way, is clockwise. So it's clockwise. When it goes the other direction, it's counterclockwise. All right. And again, if you're not sure, look above the classroom door. So now to rotate something 90 degrees counterclockwise around the origin, the rule says that what we do is we take our X and Y and we flip them around and negate the Y. So we flip our X and our Y, and then we negate the Y. So in this triangle, point W is 1, -1. W prime, well then if I flip them, the -1 and the 1, and then we negate that, which in this case negating a negative makes it a positive. So my W prime is 1, 1, and I'm actually going to draw this in just a little darker. Maybe I should use black so that we can see it a little bit better. It's hard to see these axes. So I'll just sketch them in a little bit heavier. Oops, rotating going on here. Sorry. Didn't mean to make you dizzy. So there is a really rough drawing of that axes. Okay. So we've got 1, 1 for our W prime, which would be right here. Our K is originally -3, -3. K prime, I'm just going to flip them around and negate first, so it becomes +3, -3. Okay. And then the A is -1, -4. So for my A prime, I'm going to flip around the -4, -1, and change the first to its opposite. So 4, -1. Okay. So there is our new triangle. Okay. if I'm going 180 degrees about the origin, all I'm going to do is, sorry, I didn't mean to bump that. Wrong way again. Take my X and Y values, and I just negate both. No flipping, just negate it. And notice that we don't state whether we want to do this counterclockwise or clockwise. That would be because it's going to be the same no matter what you do for the 180 degrees. And in fact, if you go 90 degrees counterclockwise, that's the same as going 270 clockwise. So if you learn the one set of rules, that's probably all you need, because we can figure it out. If you learn them clockwise, you can figure them out counterclockwise by going 90 and 270 are reciprocals of each other, or the same when you do that rotation. Same between, sorry, I'm not clear. The same between clockwise and counterclockwise, 90 and 270. All right, so here are my points. I've got J is -1, -2. So then J prime is just going to be 1, 2. Okay, E is 0, 5. E prime is going to be 0, -5. K is -3, -4. K prime is going to be 3, 4. And Z is -3, -3. So Z prime, we negate both, and we get 3, 3. Again, let me draw these axes in a little bit darker. Try to be a little bit neater. But I know some of you like the messy. Alright, so here's my axes. That's too messy. Aaron, is probably not to your liking. Alright. So J prime is 1, 2. E prime is 0, -5. I'm sorry, it should be 0, +5. Because E is 0, -5. Alright. Sorry. So 0, 5 would be E prime. Okay, K prime is going to be 3, 4. And Z prime is 3, 3. So here is my new quadrilateral. All right. Now, sometimes we're not going to be in a coordinate plane, so I've got this hexagon, and we want to find the image of the given point or segment from the rotation. Remember, this is your pre-image. Your image is what you get after you have transformed. So the first thing we need to decide is, how am I going to tell 60 degrees? Well, this is my triangle. If I start here, it's 360 degrees. So each little angle is worth 60 degrees. Okay? So if I'm going to go from X at 60 degrees, remember that I want to go counterclockwise because it doesn't tell me. So I just go one turn, and it's going to be at A. So I'm going to go from X to point A. Okay. If I want to do 180 degrees rotation around HE, okay, I'm going to kind of take one turn from here. H would go where E is. That makes it easier. E would go where X is. Okay. If I go another 60 degrees, that would be 120. So again, H would go there. E would go here. And if I would go one more, H prime, E prime would go there. So it's going to be about AG. And that would be, lost my train of thought. Oh, the order needs to be correct. All right, one last example with this. The rotation of HNO. So here is HNO and 240 degrees. So 60 divided by 240 is 40, so we're just going to make it 4 turns. So 1, 2, 3, 4. So that's going to be triangle. We're going to do it in the same order. H is the front one. So G, N, A. So H, N, O, G. Actually, we're going to switch so it's A. Nope. Yep. A, N, G. All right. One last example. We want to find the angle of rotation that maps B onto C. So again, remember polygon's 360 degrees. Let's count that up. I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So 360 divided by 8. You guys know I have to get my handy dandy calculator for that. And 45 degrees. So each turn is 45 degrees. So we can do this one of 2 ways. Okay, we said that this was 8, so we have an octagon. Okay. I could go all the way around to put B on C and add up from there because we're going to go counterclockwise. But if I go clockwise, I'm going to go 1. And so I can just do 360 minus the 45 will tell me what I've gone all the way around. So it's going to give me 315 degrees. So to go counterclockwise, it would be 315 degrees. If I was going clockwise, it's only 45. So that might reinforce what I was trying to say earlier about if we go clockwise 270, it's the same as counterclockwise 90. All right, so then what is the angle of rotation that maps C onto B? Well, we just said that's 45 degrees. Because we're just going to make 1 turn. And that maps F onto A. So I'm going to go 1, 2, 3, 4, 5 over to A. So 45 times 5 is 225 degrees. So we have looked at, so far, we've looked at translations, which were a slide. We've looked at reflections, which is a flip. And we have looked at now rotations, which is a turn. Have a great day.